but guys, let's get into our lesson. And what we're essentially chatting about today, like I said, are number patterns. Excuse me. So in the chat, can anyone tell me what a number pattern is? Or even what is a pattern? It doesn't have to be specifically a number pattern. What are patterns? You can raise your hand as well if you would like to. It might be easier to explain it in words. Bless, what is a pattern?
A list of number in a specific order, ma'am.
Okay, cool. So importantly there, we've got a list of numbers that we're working with, and they'll be in a specific order. Dixon, do you want to add to that?
I think a number pattern is a number in a specific order that a person can multiply or divide the number.
Okay, cool. So one thing that we can do when we start with number patterns is we can be multiplying our values repeatedly. What did I say? Multiplying, dividing them, adding the same number, subtracting, anything like that. So essentially a number pattern is exactly as we've said, a list of numbers or a list of values. And we call these values, specifically when we talk about number patterns, we call them terms that all follow the same rule or the same pattern. Now, when I'm talking about a rule or a pattern, it's exactly what we just said now. If we are going to times the first term by 4, we're going to times every term by 4. So this could be multiples or multiplying by a value. Oh, I can't spell by. So let's say multiplying by 3. This could be adding 2 each time. This could be subtracting 5 each time. This could be dividing by 4 each time. But as long as we're doing the same thing consistently, we have got a number pattern. We are applying the same rule every single time to get one term or to get from one term to the next. All right. Now, these number patterns, a lot of you have also said like they can come with shapes and pictures. That's very true. When we start to really get into number patterns, what we need to be mindful of is the fact that, yes, these patterns are sometimes represented with pictures. And so we need to be able to also look at a picture and see what the pattern's telling us, but we will get to those. So I'm just going to stop here for a second in case anyone wants to take a screenshot of this definition, and then we're going to have a look at some pattern examples. And then just a reminder, guys, we only put our hands up when I say so. If you have a question or you have a problem, you either post it on the chat, or remember, you can send a direct message to myself or Yolanda and we will help you. Okay, but no hands unless I've said so. There is, I think there's over 100 of us. Yeah, there's almost 120 of us. So if we've got 50 hands, it gets a little bit confusing, a little bit overwhelming. So we just need to try and remember that. All right, guys, so let's have a look at some examples dealing with number patterns. So for each of the patterns that we've got here, and there's going to be a couple, I don't really like how I've done this, so let me just do that. Hello, right, do that. So in each of the examples, we're going to do two things. We're going to write the next 3 terms, and we're going to describe the pattern in words. So I'm going to do the first one with you, and we're going to see how we do this. I'll get you to try some. But let's have a look. So our pattern that we have here is the list of numbers 3, 7, 11, 15. So the question I want to ask myself is, how do I get from 3 to 7? Am I multiplying? Am I dividing? What am I doing? And as a lot of you are putting there on the group, we are adding 4. So remember, a pattern must stay consistent. So now I want to ask myself, okay, if I have added 4 to 3 to get 7, what do I add from 7 to get 11? Again, I add 4. And so I can see that this pattern remains consistent where I'm adding 4 each time. That's not super helpful because the first part of my question, which some of you are just rushing ahead, asks you to state the next 3 terms. So I can now add 4 to 15 to get my 5th term. So if I say 15 plus 4, I get 19. And I can keep adding 4 to get my next 3 terms. So I'd get 23. And if I add 4 again, I get 27. Grade 8, I've told you no hands until I say so. Otherwise, it becomes distracting and confusing about what's going on. So please, can we lower our hands? Remember, you can put your questions in the chat. And when I say time for questions, you can raise your hand. That is when you can do it unless your question has been answered. All right, so we have done the next 3 terms because we saw what the pattern was we were adding for, so we could easily go and do that. So our next 3 terms are exactly what I've written there, 19, 23, and 27. The next thing we were asked to do is to describe the pattern in words. Now, obviously, everyone thinks and writes differently, but what the message you need to get across is that we're adding 4 each time. So we could say something like add 4, or you could write the number 4, to the previous term, or to the term, to get the next number in the pattern. And so as long as you get the message across to me or to your teacher that you know that you are adding 4 each time, however you describe it in words will sort of take. Now, often, especially in grade 8, we ask you to describe the pattern in words, so you need to be able to do that. From about grade 9, grade 10, we don't really ask you that anymore, but especially in grade 8, we do. So you need to be able to put the pattern that you're seeing into words. Right, I'm going to stop there. Now, if anyone has any questions, you can raise your hand. I'm also going to wait here in case anyone wants to take a screenshot before I give you the next one. Right, Loyiso? Loyiso, you there? There we go, okay.
So, ma'am, what you're basically saying is to get the other answer, we plus by 4.
Exactly, good.
All right, thank you, ma'am.
Good, well done. Oh, excuse me. Butle? Guys, please can we remember to mute ourselves once we have answered? Butle, I'm not, are you trying, oh, there you are. Butle, yeah?
I think Butle muted herself again. So Butle, you'll have to unmute on your side again. There we go. Butle, you can talk now.
Okay, ma'am, why are we adding plus 4?
That's the pattern that we saw. So to get from 3 to 7, we added 4. From 7 to 11, we added 4. So that's just the pattern that we were given, and that was the pattern that we identified.
Okay, ma'am.
Okay, so it won't always be adding 4. It can be anything. This specific pattern, we were adding 4.
Okay. Thank you, ma'am.
Pleasure. Right, so guys, that's actually quite an important point to take note of. Yes, in this pattern, we're adding 4, but that doesn't mean it's going to always be adding 4. We can add anything. It's just this specific pattern was adding 4. Tatum? Guys, remember, I'm implementing the 5-second rule. If you don't unmute within 5 seconds, I'm moving on. Unfortunately, there's a lot of people, and I can't be waiting. Okay, Tatum?
Miss,
Yeah.
at school there's a different way that we also started this topic today.
Okay.
So we did the same thing, but it says like constant ratio and constant difference.
Yeah, I'm not really getting into like the super specific terminologies yet, but yes, there is a constant difference, and that's what we're working with.
Yes, miss.
Good. So when I mention it, you'll know what I'm talking about. Well done.
Yes.
Tatenda?
Hello, ma'am. I wanted to ask them, is there also another way how to find the constant?
When you say the constant, the number that you're adding?
Yes, ma'am.
Yeah, there is. So if we aren't 100% sure, basically what we do is we take one term in front. So we would take term 2, which in this case is 7, and we would subtract term 1, which in this case is 3. So if we say 7 minus 3, we get our constant difference of 4. And we can do that with any, as long as it's the one before and the one after. So we could take term 3, which is 11, and subtract term 2, which is 7. And again, 11 minus 7 is 4. So if you take the difference between consecutive terms, you can get the difference there as well.
Okay, ma'am, I understand now.
Good.
Thank you.
All right, Matle?
Is it always a plus, or is it like it depends?
It depends. It can be a minus, it can be a multiply. It really just depends on what pattern we give you.
Okay, thank you.
Pleasure. And we are going to have a look at some other different types. Right, and Gideon? Okay, I'm moving on. Last one. Okay, yeah.
Hello, Miss. Can you hear me, Miss?
Yeah.
So basically, Miss, does it really matter if it's minus, divide, multiply, or plus, Miss?
No, not really. So you get, my words have escaped me. So we have specific types of patterns. So patterns where we're adding the same number each time is a specific type of pattern. Patterns where we divide or multiply is a specific type of pattern. So we can start to talk about very specific types of patterns, but right now all we're just doing is looking at patterns and seeing if we can identify patterns. But you can really do anything: multiply, divide, whatever.
Okay, Miss. Thank you, ma'am.
Good. Okay, guys, everyone else with questions, we do need to move on. Otherwise, I'm just going to spend the whole night answering questions. Please put your questions in the chat and I will, or Yolanda will answer your questions. Right. The next thing is, some of you are already jumping the gun, and I get that some of you have done this already. I get that some of you really enjoy number patterns. I understand all of that, but please let's remain focused on what I'm doing here. Reason being is because this is our very first lesson on patterns. We're just easing into it. We will get to things like finding the 100th term and all of that. We're getting there, but we're not there yet. We need to start off with the basics. All right, so if we have a look at our next number pattern, pattern B, we again need to figure out how we're getting from one value to the next. So if I think about the fact that I'm starting at -3 and then I get to -1. If you think about your number line, so if we think back, someone's not on mute, please put yourselves on mute. So if we think back to integers, I'm currently starting at -3 and I want to get to -1. I can see from my number line that that means that I have to add 2 in order to get from -3 to -1. So that is my difference here. I've added 2. If I now want to get from -1 to 1, I can again use my number line. I'm at -1. I want to get to 1. I need to add 1, 2. So I'm adding 2 again. 1 to 3, I'm adding 2. And so here what I see is that my pattern is that I'm adding 2 each time. So that means if I now want to get the next 3 terms, which is what the question asked me to do, I can add 2 to the 3 and I get 5. I can add 2 to 5 and I get 7. And I can add 2 to 7 and I get 9. So I've been able to find the next 3 numbers in my number pattern. It also means that I'm able to describe my number pattern, very similar to the last one. I add 2 to get the next term. And so just by looking at our list of numbers or our sequence of numbers, we've been able to identify our pattern and use that to figure out the next few terms. Now, grade 8s, I'm saying this probably for the 5th, 6th, 7th time. A pattern can be anything. So yes, there are patterns that we can use division or multiplication. There are patterns that we can use squaring and cubing. There are patterns where we can use subtraction. You can really do anything to get a pattern. As long as it is repetitive, it is a pattern, right? And we're going to look at these types of things. Please, like, I promise you, I'm not just going to throw you in the deep end. I know what we need to do. I know what I'm doing. I know that we need to solidify our foundations before we just jump into the trickier stuff. So we're just making sure we can look at numbers and see a pattern right now. All right, so I want you to try C. Let's see what you come up with. So C is the pattern 2, 4, 8, 16. And it keeps going. So start off by just seeing what is the pattern. What are you doing to 2 to get to 4, to 4 to get to 8 to get to 16? Remember, it can be anything. Adding, subtracting, multiplying, dividing. How do we get from one term to the next? You can pop it in the chat. Remember, the question is, I want the next 3 terms and for you to describe it in words. There shouldn't be any hands yet. Okay, no hands. Put your answers in the chat. We will deal with answers and so on just now. If you've got questions, again, put that in the chat. Don't forget, guys, I also want the next 3 terms there. So a lot of you are really nicely describing the pattern, but I still want the next 3 terms.
So y'all need to give us, there we go. You see, Butlali has given the 3 numbers. I'm not saying they're correct. Everyone, you need to give us 3 numbers. You put a number, you put a comma in, and put another number and put a comma in. Jenna, well done. I'm not saying your answers are correct. Just make sure you mark with us, okay? So we need those 3 numbers. Everybody, let's go. We are 135 of us. And that's exactly what we're going to do. Uratile, you're taking your hand down, baby girl. Take your hand down and put your answers on the chat. If you don't understand, you will ask when the time is right for questions, okay? So we know what it's doing about the pattern, but we are looking for these 3 numbers, okay? And I think majority of us have given 3 numbers. So Teacher Sam, we are all yours.
Awesome. Okay, now again, guys, as Yolanda was saying this, someone just sent a whole bunch of numbers. I think there was like 5 or 6. The question didn't ask for the next 5 or 6. It asked for 3. You need to follow the instructions of the question. If you don't follow the instructions of the question, you can be marked wrong. So please, please read your questions carefully. Right, would anyone like to raise their hand to tell me what the pattern is? So how do we get from one value to the next? Tyler?
Hi, ma'am, can you hear me?
Yes.
Okay, ma'am. So, ma'am, basically what you do is you multiply 2. Basically what you do is you multiply 2.
Perfect.
And ma'am,
Yeah?
should I say the numbers that I got
Sure.
from multiplying the others?
Yeah, give us the next 3.
Okay. I got 32, 64,
Good.
and 128.
Perfect. Well done. So guys, exactly as Tyler said, our pattern is that we are multiplying by 2. So if we want to write that out, we would multiply the term by 2, the term by 2 to get the next term. And that is how we would describe it in words. If we keep multiplying by 2, we're able to get our next 3 terms. Right, so like I say, multiplication is a pattern. As long as you're keeping it consistent, absolutely fine. All right, so I'll stop there. I'll take a screenshot. There's still hands up, so I'm assuming these are questions. If they aren't questions, you need to put your hand down.
Everybody's hands goes up. Okay, guys, so if your hand is still up, it means that you don't understand what's on the board and you want to ask a question. Hey, Akani, does that mean that you want to ask a question? Because if you don't want to ask a question, you should put your hand down. Okay, if it is for a question, yes, Akani.
No, ma'am. I wanted to answer the question.
Okay, do you agree with the answer?
Yes, ma'am.
Good, well done. All right, guys, you're taking screenshots. Butle, question?
Ma'am, can I ask? Every time you must multiply by 2 until you get infinite.
Basically, yes, that's what a number pattern is. It just keeps going to infinity. Sometimes we can stay where it stops, but for now, it just keeps going, yeah. And you just keep timesing by 2.
Until you get into infinite.
Exactly.
Okay, thank you, ma'am.
Good. Mukazi?
Ma'am, I wanted to ask that if maybe the number pattern subtractors, do you also need to times 2, multiply by 2?
Sorry, say that
If
again. You cut out a little bit. Start again.
If the number pattern subtractors, do you also need to multiply by 2?
Why would we need to multiply by 2 if we're subtracting? Unless I didn't hear. Yolanda, am I going crazy?
No, not really. See, but do you want to give us an example, girl? You can give us your own example. What do you mean by subtracting?
Like maybe when it says -2 plus -3, like when it goes on and says -6 minus, like when the number pattern subtractors, do you also multiply by 2?
Okay, so if it was something like, stop there. So if it was something like -2, -4, -6, -8, like that.
Yes.
Okay, so here we're not multiplying anything, we're just keeping on subtracting 2. So we would just keep subtracting 2 in order to carry on our number pattern.
Thank you, Miss.
Okay, I got there in the end, sorry. It took me a little bit of time. Okay, just before we put to Metswe, I see you actually got your hand up. So do you have a question? There should be a little pop-up to unmute. There we go. Okay, I can't hear you, so you might just need to double check your audio connection. And now I've lost you. Oh, there you go.
Let's go, Huitu. If not, Huitu, you can just put your question on the chat, okay? We'll be able to see it.
So you might just need to double check your audio option and that you have selected the correct audio option because we can't hear you at all.
Yeah.
All right, so last one, Letu, question?
Ma'am, I'd just like to ask if you multiply by 2 every time.
Yes. So that's our pattern. That's our pattern. We just keep multiplying by 2.
Oh, okay. Thank you.
Deja? Right, so guys, that is in essence what a pattern is. Once you've established that you're timesing by 2, you just keep repeating that pattern. You keep doing exactly the same thing until, like Butle said, to infinity, essentially. Sometimes we tell you to stop after 10 or stop after 20, but you just keep going. Okay, Pamela, just because I see your hand, last one, and then I'm moving on.
Ma'am, can you hear me?
Yeah.
I just want to ask how do you see that the pattern needs multiplication or any of design?
Okay, so that I always first check to see if I'm adding something each time. So for example, in this pattern, oh golly. So in this pattern, 2 to 4, we add 2, but 4 to 8, we add 4. And then 8 to 16, I'm adding 8. So I'm not adding the same thing each time. So the second I see that, I say, okay, let's try something else. Let's see if I'm multiplying each time. Now, there's a couple different ways you can do it, but you can almost ask yourself, 2 times what gives me 4? 2 times 2. 4 times what gives me 8? 4 times 2. And because you're multiplying by the same number every single time, that's the pattern that we're working with.
Thanks.
Okay. As we do more examples, it will become a little bit easier to see what sort of patterns we ask. But, excuse me, we essentially just need to look at our numbers and see, okay, can I times it by 2? Am I adding the same thing? And we go from there. All right, guys, so let's have a look at one more before we take a break. Also, people getting distracted in the chat, you're only doing yourself a disservice. Everyone else focus on what I'm doing. Let people who are being distracted be distracted by themselves. Right, so if we have a look at this pattern here, we have got -1, -3. There should be no hands right now. Any questions, you type in the chat. -1, -3, -5, -7. Now, guys, you need to be careful. A lot of you are saying adding 2. We're forgetting how to add integers clearly. If we think about our number line, whatever, it's not a beautiful number line, but we'll pretend it is. Right, if we think about our number line that we have here, yes, we've got positive integers, but we know we can move into the negative integers, and that's what we're doing. If you look here, you're going to a more and more negative value. You're going towards negative infinity. So you can't be adding something. It's not possible. So if we start at -1 and I go to -3, I'm moving to the left, so I'm subtracting, and I'm subtracting 2. If I go from -3 to -5, I'm moving to the left and I'm subtracting 2. And so each time I'm subtracting another 2 and another 2 and another 2 to keep getting more and more negative. That therefore means that my next 3 terms here would need to be -7. So here I am, -2, 1, 2, taking me to -9. Subtract another 2, -11. Subtract another 2, -13. So be very careful. We are not adding 2, we are subtracting 2. And so if you were to describe that in words, you would say exactly that. You are subtracting 2 to get the next term. And then I'll try and write add. Right, so again, like I say, you don't have to only be adding. You don't have to only be multiplying. Sometimes we subtract. Sometimes we divide. And your grade 8s, I told you that we were doing this question and then we were going to have a break. We need to open our ears and we need to listen, because all that's happening now is you have missed this entire example because you haven't listened to me.
Yeah, guys, let's focus. And also, it's not a must, my people, for us to have a brain break. Remember that a brain break teaches them decide on how did we behave, because we need to get on and do some work, right? So we can get into the much more difficult thing. And then we need this for everyone to get, because these are the basics. Okay, my people. So let's behave and let's wait. We might not have one.
Right. Grade 8s. I'm like warning you now, my patience is this thin today. So please, let's focus. Lexa, exactly. It's like the first one, but instead of adding, I'm subtracting. Perfect, well done. And so what we need to realize is that really we can do anything to a pattern as long as we keep repeating the same process. So I'm repeating -2, -2, -2, -2. The other one I was repeating ×2, ×2, ×2. That creates a pattern. It creates something that is repetitive, and I can see what that repetition is. That is what a pattern is. All right, I feel like I need a break. because y'all are doing my brain in. Right, here is our brain break for the day. We've got a pencil, crayon, and paintbrushes. We want to know the value of each of those in terms of what the pencil is, what a crayon is, and what the paintbrushes are, so that we can work out the value of the final equation, which is this one down here. Okay, so we're going to wait for the correct answer on the chat. Once we see the correct answer, we will ask that person to raise their hand and give us the answer. I'll go back to the questions just now for you guys to take a screenshot. Aurora's saying, I must be honest, I haven't been seeing your answers. Keep putting them there though. I do keep an eye on the chat. Like a lot of answers come through at the same time, so it might just be getting lost, but I appreciate you putting it there, so well done.
Yes, my people. Sometimes it goes so fast on the chat because we are a lot of us, and once I'm attending to one and then another question passes me by. So Oro, no worries, okay? And really, guys, we appreciate everyone's answers on the chat, okay? So please don't get frustrated. We really see your answers, and sometimes we might not mention that you have put the answer there, but we do see your answer, okay? And we appreciate that. Y'all are doing really, really well. Remember that we are striking for the final answer, okay? And once we have the final answer, we are good to go. For Naledi, a brain break is basically a time where you are stretching, you are basically just trying this sum here by doing algebra to find your answer. So you're just trying out. So basically this is like free time where you can make sure that your brain is working and we're doing something different than what you are learning now, okay? So everyone is free to do everything, stretch if you need to. We're really a lot of us here, guys. So we need to be focusing and we need to make sure that we do listen to each other's questions like this. We don't repeat, okay? But it's for fun thing. Oh.
I do see your answers coming through. I'm going to be honest. I don't know if it's just because I'm having a bad Monday, but something's not making sense to me here. So I'm just trying to figure it out in my brain here.
No problem. Aleta, so if you have a question or an answer, you can put it on the chat, okay? So remember that we forbid everybody to raise their hand without Teacher Sam saying raise your hand. So Kutelo, I'm lowering your hand down. You need to make sure that you lower your hand down. So if you have any answer, everybody, you just have to put it on the chat, okay?
Guys, this should be 132. I was looking at this now and this made absolutely no sense. So this should say 132, not 150. Otherwise that makes
and
no
I think
sense.
I think Blessing also got that part. Blessing was like, ma'am, I think there's a mistake.
Well done, Blessing.
So Blessing, well done. I hope that was also the mistake that you saw.
No, I'm going crazy. 130 is right. I just can't. Today is not my day. 130 is right. I'm sorry. It's fine. That's where I'm at in life, guys.
I see a lot of people getting 132 as their final answer. Let's see, guys, if y'all did right or not. Let's see it.
Yo, I'm hoping I've got this right because anything's possible today. I might be doing this one with you guys because chaos.
Yeah, we can all do it all together, guys.
I think let's do this together. Right.
Yeah.
So, and like, again, hopefully I'm being able to focus today, but I also acknowledge that today's not been my day. So if we've got 3 of the same pencils, we're adding 10 plus 10 plus 10. They're exactly the same. They have to represent the same value. So 1 pencil is 10. So every time I see a pencil, I know that value is 10. If I now move to my second step, we've got 10 times the crayon, plus that same crayon must be 66. So I know that my crayon is 6 because 10 times 6, remember we do BODMAS, is 60, plus 6 gives me 66. Now, when I see a double crayon, I have to double its value. So if 1 crayon is 6, 2 crayons is 12. So now I know double crayons is 12. And now I need to work out my paint brushes. Ooh. So the paint brushes here, again, we need to apply BODMAS. 12 times what plus the same number must give me 130. So 12 times 10 is 120, plus 10 is 130. So the double paint brushes is 10, which means in my last step, I can now, again, I have to apply, don't know what's happening. I have to apply BODMAS because my order of operations is very important. So I do the 12 times 10 first, which gives me 120, plus the 10 gives me 130. So we actually get 130 twice in our calculations, but we only got that last 130 by essentially working out the value of our crayon, paint brushes, and pencil. Right, so that's essentially your brain break. Brain break, again, guys, just we take a break. Sometimes we just need a break. Alrighty. So those of you who are asking for screenshots of the notes earlier, I'm about to go back, so make sure you get screenshots when I'm there.
And well done, guys. Y'all did well. I saw some of you had what is an answer. Y'all well done. And so for the brain break is not that long. It's just for you to stretch and to think.
Yeah, we're done. Right, so there's the question that some of you wanted screenshots for. There it is. Take your screenshots. And then we're moving on. And again, guys, no hands. If you have questions, put it on the chat, or you wait until I say you can now raise your hand for questions. All right, so let's have a look at question E. Now, this is, again, like, it doesn't have to be what we think it's going to, oh no, let me start that sentence again. It doesn't only have to be adding or subtracting or timesing by the same value each time. Like I said, sometimes we've got squares and cubes and stuff that we need to bear in mind. And so if we now have a look at question E, we've got the numbers 1, 4, 9, 16. Grade 8s. The break is over. We are looking at another example. The subtraction of 2 we have done. I have done this example. It is done. It is over. If you weren't listening, you need to go and watch the recording. I am now on question E, and we are trying to figure out what the pattern is here. So let's see. From 1 to 4, I add 3. But now from 4 to 9, I add 5. From 9 to 16, I add 7. So this is a pattern for sure. I'm going up in consecutive odd numbers, and let's write that down so that we all know what that means. I am adding consecutive, and consecutive means one after the other. So 1, 3, 5, 7, 9, 11 keeps going in its own pattern. That's not how you spell consecutive. Let's try that again. Consecutive odd numbers. And so that's definitely a pattern that I've identified, which means that the next one that I add should be 9. So I get 25. The next one that I add should be 11, giving me 36. The next one that I add should be 13, giving me 49. But I really hope that we're also noticing that these numbers are also very special types of numbers over and above that. If we look at these numbers that I've got here, they are what we call perfect square numbers. And the reason they are perfect squares is if I take 1 squared, I get 1. 2 squared is 4. 3 squared is 9. 4 squared, 16. And so we can keep going on in the pattern. 5 squared, 25. 6 squared, 36. 7 squared, 49. And so another way to see this pattern is that you are squaring your terms in order to get the value. So I'm saying squaring the position, and all I mean by that is this is the first term, the second term, the third term, etc. I can't spell position, but whatever. So if you also notice that they are perfect square numbers, that is absolutely fine as well. Or you saw that you were adding consecutive odd numbers, also absolutely fine. So Owami, you've also, sorry, not Owami, let me just go back to my chat. Nosipo, you've said you're adding numbers at the bottom, you're adding a 2. Yes, absolutely. If we now look at 3 to 5, we add 2. 5 to 7, we add 2. That is what consecutive odd numbers is. Because they're odd numbers, I'm skipping all the even numbers. So I have to add 2 to get to the next odd number. So there's patterns like this that we can get, guys, where essentially we can be working with perfect squares, or we can be adding consecutive odd numbers or consecutive even numbers as we move up along our pattern. So adding 3, then adding 5, then adding 7, then 9, 11, etc., etc. They are consecutive odd numbers. Right. So yes, but just be careful. It's not to the original term. It's to what we added to the term before. So I'm adding 2 to the 3 that I added to the first term to get the second term. Then I'm adding 2 to 5. If we were adding 2 to the terms, we would be saying 1 plus 2 is 3. 3 plus 2 is 5. The terms, remember guys, are these numbers in the actual number list. These are the terms. So just be careful. Yes, we are adding 2, but it's not to the specific term. It's to our differences, essentially. Right, I'm going to stop here for you to take a screenshot. I'm also going to stop here in case anyone has any questions that they'd like to raise their hand. Charlotte, I'm not too sure what you mean by would they the same. So just, you might need to raise your hand to explain that to me. Butle?
And don't look out, guys. Today is polls day, so don't look out.
Can you hear me?
Yeah.
Why are we adding different numbers here?
Excuse me, why are we?
Adding different numbers.
Because that's the pattern. The pattern here just is that we're adding odd numbers to get the next one. Patterns can be anything. It just so happens that this pattern is adding odd numbers.
But on top, ma'am, you are saying 1 squared 2, it's 1. Then 2 squared, it's 2, it's 4. How come, ma'am?
So that's another way to look at the pattern. Either you look at it that you are adding consecutive odd numbers, or you could see this as perfect square numbers. There's 2 ways to describe this pattern.
I was just asking why we are adding 2 different numbers there.
What do you mean 2 different numbers? Which 2 different numbers? The 3 and the 5 and the 7 and the 9.
You said 8 plus 3, 1, and 4 plus 3, and then you say plus 5 plus 7 plus 9 plus 11
Because
plus
that's
10.
the pattern. You're adding odd numbers. You can't add the same odd number because then it doesn't give us that pattern. The pattern is that I'm going up in odd numbers. So I first added 3, then I added my next odd number, which is 5. Then I added my next odd number, which is 7. So we're going up in odd numbers.
Oh, you add odd numbers.
Exactly.
Okay, ma'am, thank you.
Good. Okay, I'm going to try to pick people who haven't asked yet. Botale?
On top of that, can I just run my poll because I see it's
Yeah.
even getting late? Okay. Please vote, my people.
Okay, Botale, question quickly.
So, ma'am, like I was asking that, ma'am, is it also like possible if we can have like, let's say, ma'am, the bottom numbers that you're adding, ma'am, it can be also like, let's say +2, then it goes to +20 and so on.
It could, but it needs to maintain the same pattern. But yeah, it could.
Okay, thank you, ma'am.
Good. Okay, and then Charlotte, just explain to me what your question was. Maybe I need to unmute you. Hey, that would help. There we go.
Ma'am,
Yeah.
so because adding consecutive odd numbers and squaring the numbers give you the same answer, would that be the same thing in this case?
Yes. So in this case, you could describe it in 2 different ways. Yeah.
Oh, okay, then thank you.
Yeah, sure. Right, so guys, please make sure you do that poll. It's there for you. We are carrying on with patterns on Wednesday, so please save your questions, save all your concerns for then. We have to go to the next class, and I get that there's questions still, so keep them. Try and join the class early on Wednesday so that we can deal with those questions before we start, but we are going to do more of this on Wednesday.